Hello everybody, my name is Chaitra. Today we are going to talk about ER diagrams, constraints and cardinality ratios. Let us start by giving the introduction of ER diagrams. ER diagrams are a visual tool used to model and design databases. They help represent the entities, attributes and relationships within a database system, providing a blueprint for the development. Entities and attributes. Entities represent the main objects or concepts being modeled in the database, such as customers, products, or orders. Attributes. Attributes describe the properties or characteristics of an entity, like a customer's name, address, or a phone number. Keys. Keys attributes uniquely identify each entity instance, such as customer ID or product scope. Relationships and cardinality. Relationships define the associations between entities, like a customer placing orders or a product being sold in a category. Cardinality. Cardinality specifies the number of instances of one entity that can be associated with each instance of another entity. Types. Common relationship types include one to one, one to many, and many to many. Identifying weak entities. Weak entities depend on the existence of another strong entity, and it cannot be uniquely identified without it. Now, identifying attributes. Weak entities have partial key attributes that, when combined with the primary key of the strong entity, form a unique identifier. Examples. Common examples of weak entities include order details, dependent family members, and product variations. Relationship constraints. Mandatory. Entities must participate in the relationship, such as customer always having at least one order. Optional. Entities may or may not participate in the relationship, such as a customer having zero or more orders. Exclusive. An entity can only participate in one of the relationships, such as product being sold in only one category. Non exclusive. An entity can participate in multiple relationships, such as product being sold in multiple categories. Cardinality ratios 1 to 1. Each instance of one entity, it is associated with at most one instance of another entity, and vice versa. 1 to many. Each instance of one entity can be associated with zero or more instances of another entity, but each instance of the other entity, it is associated with at most one instance of the first entity. Many to many. Each instance of one entity can be associated with zero or more instances of another entity, and each existence of the other entity, it can be associated with zero or more instances of the first entity. Implementing ER diagrams in a database design. Conceptual model. The ER diagrams represent the high level conceptual model of the database. Logical model. The conceptual model is then translated into a logical data model, such as tables and columns. Physical model. The logical model is finally implemented as its structure. Conclusions and key takeaways. ER diagrams. It provides a visual blueprint for a database design. Entities and attributes. It represents the main objects and their properties. Relationships and cardinality. It will be defining the associations and their multiplicity. Weak entities. It entities that depend on others for the identification. Constraints and ratios. It will specify the rules and the limitations